The third type of problem you're going to see today moves away from graphs, so that's not always a good thing. We are going to get into the idea of continuously compounded interest. And this is something we'll talk a little bit more during class about what compound interest means and just interest in general. But just so you kind of have an idea, compounded interest is talking about how often interest is added to an account. So like let's say you have a bank account that earns 2% interest, okay? However often that interest is added to your account makes a difference because let's say that interest is added once a year. Well, if it's only added once a year, you're not going to start earning interest on the interest that was added until it's already in there. So if your interest was added every day, for example, the interest that gets added in my account today is going to earn interest tomorrow. And that's going to change the amount of money pretty quickly. So again, we'll talk more about what compounded interest means and exactly how all of that financial stuff works. But so you have a general idea. So for section 1, we saw just like straight percent growth. This is getting into some more specific examples. Our formula for continuously compounded interest is y equals p times e to the RT power. A lot of times you'll hear people call this PERT, but y equals p times e to the RT power. And e is a number. E is called the natural base. And it's a number just like pi is a number. It's irrational. E is about 2.718, and then again it keeps going, it's irrational. P stands for the principal. And principal in financial terms is your starting amount, essentially. So the same setup as your straight exponential function. Your number in front tells you your start value. The R here is your interest rate. Written as a decimal. And then T is the time in years. The fact that this is in years is kind of key here. So y equals p e to the RT is the big thing you have to remember. Let's see an example here. Suppose you won a contest. At the start of 9th grade, that deposited $3,000 in an account that pays 5% interest compounded continuously. So if it's compounded continuously, that means that interest is constantly being added to your account. You start college 4 years later and spend 4 years in college. How much will be in the account by the time you graduate? So we're after your 4 years of high school, after your 4 years of college. Well, the first thing we're going to have to do is write our equation. And our key here is that our situation is compounded continuously. Whenever you see that word compounded or the phrase compounded continuously, that's your clue. This is your formula you have to use. So anytime you see the word continuously, this is what you want to work with. Let's start off. Y equals P. Principal, what is that going to be in this case? Well, principal's our starting amount. And that's $3,000 here. Don't really need that dollar sign. Times E, which is our number, to the RT power. R is our interest rate as a decimal, and we have 5% interest. 5% is 0.05 times T, our time in years. We have 8 years total. Okay. So to get our answer, we just type this in our calculator. $3,000. And E, the button for E is right underneath where pi is, the second division sign, to the 0.05 times 8 power. So after your 4 years of high school, 4 years of college, that $3,000 turns into $4,475.47. That's pretty good. So in your 8 years, your $3,000 increased by almost $1,500.